In this video, we are going to talk about conditional probability. So far, the probabilities we have discussed are all unconditional probabilities. That means we did not impose any condition on the probabilities themselves. Let's take an example. We assume that chances of iPhone sales going up next year is 40%. But if someone wants to know that what's the chance of Apple going up or iPhone sales going up next year if there is a financial crisis or there is an economic recession, okay? How does that probability change in that context? So here we are basically trying to impose a condition that if certain event happens, what would be the probability of iPhone sales? That would be a conditional probability. Similarly, if we go back to our soccer World Cup example, chances of Brazil winning the World Cup was 40% in our assumption. Now, but if a key player for Brazil was injured, how that probability changes. So this is called conditional probability when we try to assess probabilities under certain conditions. Okay, so for example, with Apple iPhone sales, our initial assumption that iPhone sales going up next year was 40%. So 40%, or you can also say 0.4. But when I impose a condition on that, what I do is I say probability of iPhone sales going up conditional to a certain thing, let's say bad economic condition. So let me put conditional to another event B, which is bad economic condition. I write it as this, probability of iPhone sales going up conditional to a certain bad event happening. So this is probability of A conditional to B, which will be equal to something you can estimate, which is, if by some estimation you come to know that if the economy is really bad, iPhone sales chance of going up is going to decline to something like, let's say, 20% or 0.2. Okay, so that's the difference between unconditional and conditional probability. Unconditional probability gives you the chances of iPhone sales going up in general, but conditional probability is specific. Under certain condition, what will be the chance of iPhone sales going up? And that we see in this context comes down to 20%. There is many a case where insurance companies also use conditional probabilities. Let me give you a quick example. Insurance companies often use conditional probability to assess premiums of their customers. Let's say an insurance company found out the chance of customers making claims in general. They analyzed the data and they found out that probability of a customer making a claim, let's say probability of making a claim is probability of A is 3%. Okay, so 3% or 0.03. Okay, so that's in general, customers make claim. About 3% customers come back and make a claim in a given year. However, let's say they analyzed the data more thoroughly and found out that customers who drive interstate, that chance changes. Okay, so for customers who are driving interstate, the probability actually goes up to 5%. So let's represent that. Probability of an accident or making a claim, which is A, conditional to the customer being driving interstate, which is B, okay? And that goes up to 5%. So that would be 0.05. And similarly, you can have another condition when the customer is driving within locally within a radius of 20 kilometers, let's say. So the insurance company can also find out that probability by analyzing the claim record of those customers. So in this case, let's say probability of customers who drive a short distance, and we call that, let's say, C. Okay, so and that chance drops to 1%. Okay, or in other words, 0.01. So basically you can see that we are assessing the same chance of making an accident and claim, but when we impose different conditions on that probability, the numbers look different. And what this tells us is or what this may tell the insurance company is that these two events, which is chance of having an accident or making a claim and how far the customer is driving, could be related. Okay, there must be a link between the two, and that in that case they may actually assess certain customers as more risk-prone customers, and those business as more risky business, and then they can charge the premium accordingly. So it is a very helpful concept for them to understand the difference between the unconditional probability, which is one for all customers, 3%. But if you look at the conditional probabilities, that number really changes. Let's say if by chance we come up with numbers which are pretty much the same. For example, customers who are driving interstate, they're also having a probability of accident or making a claim as 3% or 0.03. And similarly, customers who are driving locally also have a chance of making a claim as 3%. In that case, the insurance company's conclusions would be different because the unconditional probability of 3% is the same as the conditional probabilities, which are also 3%. So in that case, the insurance company will conclude that these two events are independent. That means they're not related to each other. Chance of having an accident and chance, of driving locally, these two things are completely independent. And that's why the numbers look up the same. So to conclude, for dependent events, conditional and unconditional probability would be different. For events which are independent or unrelated, you would not see any difference between conditional and unconditional probabilities. With conditional probabilities, there is a rule called multiplication rule, as you see here. And the multiplication rule can be shown as this, that probability of two things happening together, which is A and B, is equal to probability A conditional to B times probability of B. So just to bring the example we just did into this particular formula, what we can say is chance of having an accident conditional to somebody driving interstate, which we found as let's say 0.05, and apologies for my handwriting here, times chance of being a customer who is driving interstate. So the company has to know that what's the probability that the customer would be driving interstate. And if they found that the probability of their customers driving interstate is something like 0.1 or 10%. So basically that means that probability of A and B, which is customers having to make a claim and also driving interstate, that would be basically a product of these two. So 0.05 times 0.01. So and the result here would be 0.005. So that means there is a 5 in 1,000 chance that a customer would be driving interstate and also would be making a claim. So that's 5 in 1,000, so that's a 0.5% chance of these type of situations arising. So that's the multiplication rule for events which involve conditional probabilities. To make sure that we really understand the dependence and independence between events using conditional and unconditional probabilities, let's go through this example. An advertising company wants to find out if there is a relationship between gender and the type of car driven. Type of car, by that we mean in this particular example as the size of the car, whether it's a big car or a small car. So does it have anything to do with the person's gender who is driving it? So let's say the company has actually surveyed 200 cars on a particular freeway here called SE or Southeast Freeway. And this is what the data looks like. So they just note the car numbers, serial numbers 1, 2, 3, 4, and then type of the car, which is indicated by either big or small. So B stands for big and S for small. And they also note the gender of the person, which is whether it's a female or a male, and that is indicated here. And that information now, once we have gathered all the data, we have put it in a frequency table here. And you can see the frequency table has the rows and columns because we have two different variables here. One is gender, and the other is the car size or car type in this case, big, small. So all 200 people who were surveyed, they appear here. Now, how do we assess whether gender is related or unrelated to the size of the car? We simply try to find out first the unconditional probability of driving a certain type of car. For example, what's the chance a person will be driving, let's say, a big car? Okay, so let's call that probability of driving a big car. And so I'll write BIG, probability of driving a big car, and you can see that number of big cars were 80 out of all 200 cars. So if I just randomly pick up someone from this 200 people, the chance that the person will be driving a big car would certainly be equal to 80 divided by 200. So that means there is a 40% chance. So the answer is 0.4 or 40%. So there's a 40% chance that a random person picked up from this sample would be driving a big car. So that's the unconditional probability because we are talking about a random person without imposing any condition. However, if we impose a condition, for example, what's the probability of driving a big car? Okay, big. If that person happens to be a female, let's say. So I'm imposing a condition here, okay? So I'll put big conditional to female. I'll just simply write F here. So this is now changed from a unconditional probability of driving a big car to a conditional probability. So chance of driving a big car if the person is a female, so I will just look at the female column now. So if I just randomly pick up a female person, what's the chance that person will be driving a big car? And you can see out of a total of 50 female, and if I randomly pick up anyone out of this 50, the 10 female actually were driving a big car. So the chance of that happening would be 10 divided by 50. So now I'm not considering all survey participants, but only the female ones, because that's the condition I have imposed. So 10 out of 50, so that is basically 20% or 0.2. So you can see the unconditional probability of driving a big car was 40%. Now the conditional probability of driving a big car, the condition being the person is a female, drops to 20%. So obviously in this case, you have a strong evidence to conclude that these two things are related, that the size of the car and the gender of the person would be related. If they were not, these two probabilities would be looking pretty much the same. Thank you.